Hi, welcome to Hubble's Universe Unfiltered. I'm Dr. Frank Summers of the Space Telescope Science Institute. Today, we're going to talk about everyone's favorite X-planet, Pluto. And really, we're going to go back to the very beginning, because this is the very first image ever taken of Pluto. Although, we didn't actually know Pluto was in this image until another image was taken about a week later, and Pluto was discovered. What were they doing? Well, Clyde Tombaugh was taking separate plates of the sky and was looking for objects that move between images. Stars, which are really, really far away, don't move between those images, but objects within the solar system have a little bit of motion due to the Earth's motion and due to their own motion that causes them to move on these images over the course of a week. Now, if you ask me, I probably couldn't point out where Pluto is on this image, so I've added some arrows to it. And on January 23rd, this little dot there is Pluto. And we know because on January 29th, that little dot had moved to there. That's it. That's the discovery of Pluto, that a dot moved from here to here over the course of a week. Now you can see that this very first image of Pluto wasn't much to look at. It's just a dot. So we really couldn't tell that much about Pluto. The prediction by Percival Lowell that Pluto existed, well, was based upon the idea that there was a massive object out beyond Neptune and that it was somehow perturbing Neptune's orbit. Turns out that, well, Lowell was wrong. It wasn't a massive object. When he made his prediction back in 1910, he estimated Pluto's mass to be 5 times the mass of Earth. Very quickly after Pluto's discovery, we found out that, well, at best, it's about the same mass as Earth. But if it's the same mass as Earth, it's a planet, right? So that's pretty respectable. However, over the years, Pluto became known as the incredible shrinking planet, because by 1970, we had already determined that the maximum mass Pluto could have is about 1/10 the mass of Earth. And then again by 1980, as observations got better and better, we found out that it was only at most 1/100th the mass of Earth. Now, there was a joke made around this time that if Pluto kept losing mass at this rate, it would eventually disappear before the year 2000. Well, that didn't happen, because there was an observation made around this time that discovered Pluto's moon Charon. Now, this is an image of Pluto where you can see it sort of has this bump over here. You can't separate the two objects, but this is Pluto, and this bump here is Pluto's moon Charon. This is not the discovery image. This is actually a much better image than the discovery image. The discovery image is very fuzzy. But here you can see that, you see these little squares. These are the individual pixels of the image, and it's barely that you can see that we've got Pluto and we've got Charon. Well, in discovering Pluto's moon, we were then able to get the gravitational interaction between the planet and moon and estimate the mass of Pluto. Turns out that it's less massive than our moon. Pluto is a very small object. It's not totally disappeared, but its mass is turned out to be very, very low. Now, when Hubble was launched, Hubble was very quickly able to take a look at Pluto, and even with the flaw in the mirror, Hubble was able to distinguish between Pluto and its moon Charon. Okay? You can easily see Pluto, you can easily see its moon Charon. You can see lots of scattered light around here. That's due to the flaw in Hubble's mirror that was uncorrected at this time these images were taken. In 1994, after the flaw in Hubble's mirror had been corrected, we were able to take this image of Pluto, these two images actually, and you can see again there are very, very pixelated images of Pluto, but here we're actually seeing, about 10 or so pixels across the disk of Pluto. All right, we're actually resolving Pluto into multiple pixels. This is really good. However, I gotta tell you, this is like the best image of Pluto. All right? It's very small and it's very far away. So we can't really tell much about what Pluto's surface looks like. Well, what you can do is you can combine an image like this, an image like this, and a whole bunch of images and put them through computer processing to try and determine what Pluto looks like on a finer scale. That's what we did in 1994, and we released these two maps. I call them maps because these aren't images of Pluto. They are taking those images that we have of Pluto and turning them into maps of what the surface probably looks like. We don't know exactly in detail, but we can tell that Pluto's surface has some bright spots and it has some dark spots. And at this time it was mostly just gray due to the filters that we took. Well, this was in 1994. And since then, our resolution of Pluto hasn't gone up that much, so we don't have even greater resolution to show you of Pluto. But what has increased in that ensuing decade is the amount of computer processing power that we can throw at it, and we have new filters on Hubble. So in 2002 to 2003, we took a series of images of Pluto, and we were able to get much better maps of Pluto. And here are the images that we released. Actually, we only released them in 2010 because it took so long to do the computer processing of these images. We worked on these images for years and years to try and find as much detail in them. You'll also notice that there's some yellow color, all right, which is due to the various filters. Although, I got to be honest with you, I think the yellow colors are a bit overdone in this presentation here. I don't think that if we actually got up to Pluto and looked at it, we'd have quite so bright a yellow, but there would be a yellowish tinge, I'm sure. So what we've done is we've gotten a lot more images of Pluto, and we can actually take a look at Pluto as a globe. Here is a scientific visualization of Pluto where we've got the entire globe of Pluto spinning in front of you. And you can see the bright spots, you can see the dark spots, you can see the sort of yellowish tinge around it. So, this is the best map we have of Pluto, and here it is presented in a globe. But for science, it's actually a little better if we present it in a longitude-latitude map, sort of like a map you might spread out on a table in front of you. On this axis, we have the latitude on Pluto, and on this axis, we have the longitude on Pluto. So this is the map of Pluto from 2002-2003 that we released in 2010. And I gotta say, when I first look at it, it reminds me of something totally different, although similar. It reminds me of a map from 1890 by Schiaparelli of Mars. And this is a very infamous map because this is the map from Schiaparelli where he thought he saw these canali on Mars, or channels on Mars. And this is, looking at Mars through a ground-based telescope that didn't have a great view of Mars, and it's kind of fuzzy. And so he saw all of these dark and light splotches, and he had these straight lines that he called the channels on Mars. This map was the inspiration for what I call Percival Lowell's greatest mistake, which was when he misinterpreted canali, meaning channels, into actual canals, and came up with the idea that there were civilizations on Mars, and they were trying to get water from the poles to the equator through this great system of canals. Well, turns out that was not true. Here, what I want to use this to illustrate is that our knowledge of Pluto is approximately the same as our knowledge of Mars about 120 years ago. So this is our knowledge of Pluto today. And it's really not the bright spots and dark spots, but really it's the change in the bright and dark spots since 1994. Here is the current map, and if we go back to the 1994 map, you can see the pattern has changed a bit. Let me do that again. Going to the 2002 map, and then the 1994 map. What you can see when you do the comparison is that in 1994, the brighter regions were in Pluto's southern hemisphere, and in 2002, the brighter regions are in Pluto's northern hemisphere. What could cause this? Well, it's actually the same thing that happens on Mars every year. On Mars, the northern and southern polar caps, made of carbon dioxide ice, the ices go straight into gas, travel to the other pole, and then condense out. So the poles go from ice being at one pole to ice being at the other pole. This is also what we think is happening on Pluto. The ices that were down here have sublimated out, gone through the atmosphere, and condensed out down here. Now, as I said, on Mars that happens every year. On Pluto, a year is 250 Earth years happening. Okay? So why would this happen when you would expect it to take, half of a Pluto orbit, or over 100 years for something like this to happen? Well, that has to do with the shape of Pluto's orbit. Here are the shapes of the orbits of the gas giant planets: Jupiter, Saturn, Uranus, and Neptune. You can see they're relatively circular. But Pluto's orbit is relatively elliptical in comparison. This is Pluto's orbit, and as you can see, it gets in as close as the orbit of Neptune, and it gets as far away from the Sun as about 1.5 times the orbit of Neptune. So it's much, much closer when it's close than it is farther. And right now, Pluto has just passed its closest approach to the Sun. It's about a decade or so past its closest approach to the Sun, and is now moving away. That process of moving away has caused the seasons to happen much, much faster, or the seasonal change to occur in about a decade on Pluto, where you would expect it to take about a quarter of an orbit on another planet. It can happen in a very short time on Pluto. And so we're seeing the ices move from pole to pole relatively quickly on Pluto. Now, you're probably asking, all right, when are we going to get confirmation of more details? When are we going to see what's really happening on Pluto? Well, the answer for that will be provided by this launch, which is the launch of the New Horizons mission. The New Horizons mission is already on its way to Pluto, and it will arrive in about 2015. And here is an artist's depiction of the New Horizons, along with Pluto and Charon, along with its other two moons, Nix and Hydra, which were discovered by Hubble back in 2006. Now, for 6 months during its closest approach to Pluto, New Horizons will finally have greater resolution than Hubble does. Only it gets really has to travel for many, many years to get up close to Pluto, and finally New Horizons will be able to have much finer resolution and see details that Hubble can't see. So we have to wait about 5 years, but we will get more detailed observations of Pluto. Further, New Horizons is going to do something important even after it goes past Pluto and Charon. It's going to go on out and visit a region of the solar system we call the Kuiper Belt. Now, this is the orbit of Neptune. And all of these dots out here are objects in this region of the solar system called the Kuiper Belt. Pluto was discovered in 1930. Charon was discovered in 1978. Well, all of these objects, and there are over 1,200 of them, have been discovered in the last 2 decades, basically since 1993. We have discovered a whole new region of the solar system. These are small bodies. They are icy bodies. They have elliptical orbits. They have tilted orbits. Their characteristics are very, very similar to what Pluto's characteristics are. The Kuiper Belt is the reason why Pluto is no longer a planet. It doesn't fit in with the terrestrial planets, Mercury, Venus, Earth, and Mars. It doesn't fit in with the giant planets, Jupiter, Saturn, Uranus, and Neptune, but it does fit in with the Kuiper Belt. It is no longer the ugly duckling amongst the planets. Instead, it's one of the largest objects in a new region of the solar system. And we will get to explore that solar system starting in about 2015 after New Horizons passes Pluto, and then we'll go on to hopefully explore in detail some of these Kuiper Belt objects. So that's the story of Pluto, from 1930 seeing it as just this tiny little dot on a photographic plate, down through understanding it more and more and seeing it, our knowledge of it shrinking and shrinking, until finally when Hubble was able to start to see some pixels, and in the future, in 2015, we'll be able to see even more. Thanks for joining us. We'll see you next time on Hubble's Universe Unfiltered.